I'm Tony D'Amato. I guess I also somewhat am representing Massachusetts, my home state, but sitting up here in Vermont on a nice snowy day, finally in this part of the world. And I'll be co-presenting today with Kevin Evans from Dartmouth College Woodlands. And so I appreciate everybody being on the webinar today. And it's always awkward sitting in your office doing these. Wish I could be there with you all in person, but we'll get through this together. So what the goal is today really is to talk a bit about some broad concepts as it relates to assisted migration, kind of how it fits into at least some thinking around forest adaptation, and then really specifically hone in on the Northeastern region. And based on that poll, it looks like more than half of you are from the Northeast. Those that aren't from the Northeast, I think, depending on where you're from, you're going to pick up on some unique challenges that we might face in this part of the world as it relates to actually operationalizing adaptation strategies that include planting as part of assisted migration approaches. And so Kevin will speak more to that as we get into this presentation, but really the goal here is to talk about some broad ideas around assisted migration, how it fits into the broader portfolio of things that we're evaluating as adaptation strategies, and then really hone in on a specific landscape in northern New Hampshire. How did this actually play out as a forest operation in our region? So what's worth always kind of reflecting on when we're talking about adaptation, here we go, oftentimes when we start discussing assisted migration, one of the main areas of emphasis is trying to plant tree species in response to future changes in climate. And so the upper right-hand corner is one of many examples of the great work that's being done as part of the Climate Change Tree Atlas by Lewis Iverson, Prasad, and others, showing kind of shifts in potential suitable habitat for sugar maple on the left, red oak on the right. And oftentimes we're thinking about those changing suitabilities of habitat and how might we kind of account for those as it relates to climate change. But really when we're talking about adaptation and also thinking about assisted migration, is also a tool that we might be integrating to address other both present as well as emerging stressors like invasive insects and diseases, invasive plants, changing disturbance regimes, and really packaging all these different strategies into kind of a holistic approach on the ground that's addressing both future climate change, but also kind of this broader suite of stressors and dynamics that are going on in the landscape, including kind of the lack of winter that we've just been having for the past 2 months. So when we talk about assisted migration and think about species migration, we have a pretty good understanding of how species have historically responded to past climate, and really a very rich understanding of that, specifically for the Northeast, especially southern New England. And so the figures you see on the right-hand side are a summary of some work that was done by the Harvard Forest and many years of study, if not decades of work, looking at kind of shifts in species abundance following the last glaciation. And so the upper left-hand corner shows 14,000 years before present, 10,000 years before present, all the way to 1,000 years before present. And what they're showing just with the coding is what the dominant species were in pollen diagrams during that time period. So most of us are familiar with this general narrative, but we had spruce, kind of coming in, following the ice sheet, so kind of tundra, and then into the spruce-dominated ecosystem. Species like white pine, hemlock, birch starting to show up about 10,000 years ago. And if we bring it to kind of the current day, or even 1,000 years ago, we see what reflects a lot of what we think of in the current environment. So things like oak, chestnut, hickory, kind of in southern New England, beech oak as we move through this transition zone, and then much more into hemlock, maple as we get further into northern New England. And if we look at those changes and evaluate, well, how fast were species actually migrating historically, what they've estimated is about 1/10 to 3/10 of a mile per year was kind of the shift that they were seeing in the abundance and occurrence of a given species. And so we know that species can migrate naturally in response to changes in climate and changes in suitable habitat. But the challenge and the reason why we're talking today about assisted migration in this webinar, and certainly more broadly as it relates to adaptation, is that what we're seeing in terms of climate regimes is that they're changing at a much faster rate than natural migration historically has shown to be able to keep pace with. And so the estimates are about, we're kind of shifting our climate about 4 to 6 miles per year. And we generally feel, and I've actually been able to see already in inventory data, that species aren't really able to track that change rapidly enough. And so there's this potential for what folks are calling this kind of recruitment deficit, or these lags in migration, that the climate might be perfectly suitable for red oak in a given area, but it's just not able to get there quick enough to capitalize on that new environment. And so what's come up as a discussion is, should we now be integrating, at least from a management perspective, some assisted migration to actually account for these shifting dynamics? and actually get species into places we think they might be suited for in the future. So there's various discussions around assisted migration, both in the conservation community, but also more broadly in the forestry community. And so there's different forms that assisted migration can take. But several years ago, Leach and others and Williams and Dumrose kind of summarized the 3 forms of assisted migration that we might apply as it relates to forestry applications. And these really kind of move down kind of a gradient of controversy. Starting with the least controversial, what we would term assisted population expansion. And basically this can often be thought of a little bit like enrichment planting. You're planting a species, but you're planting it within its range, so you're not moving it outside of its range. And really what you're trying to do is increase the representation of that species within its range because you feel that it's already adapted to the current climate, and it's also very likely to be adapted to the future climate. You might, within the species range, choose seed lots or genotypes from other portions within that range, maybe from the south, and plant those southern seed sources to the north, but you're not pushing that species somewhere where it's not currently found kind of broadly across the region. The next one, and the one that I think many of us often think about, is assisted range expansion, where instead of moving just within the current range of that population, you're now nudging kind of the distribution of that species just a little bit, so planting just adjacent to the current range of that species, so maybe just to the north of where that species currently exists, or just to the west of where that species currently exists. And really what you're trying to do is take a species from a given climate today and putting it into an area where the projected climate is likely to be similar, and so trying to match that climate going forward. And the final one, the most controversial, and ironically the one we have the most experience with in the Northeast, is the translocation of exotics. And our experience with this really was, 110 years ago through the 1930s, which was planting things like Norway spruce, Scots pine, Japanese larch, European larch, all over our landscape. So taking things from other regions, putting them into our region, kind of well outside their current range, either for, in that case, it was for commercial and conservation purposes, or for other reasons. So just to look at that from a diagrammatic standpoint, again, borrowing from Williams and Dumrose's work on this, the left-hand side is just showing kind of this assisted population expansion. So here's a species' current range, and all you're doing is planting that species within its range. Again, you might use a seed source from further south and plant it in the northern portion of its range, but you're not really pushing that species into areas where it isn't currently found broadly across the landscape. Assisted range expansion, not a dramatic change, but you're nudging that species distribution either to the north, south, east, west, depending on what climate or condition you're adapting to. And so actually are moving that material outside of the current range of that species. And then finally, translocation, you're taking that material far outside of the range, again, oftentimes even outside of the continent that it's currently existing on. So given this is a NIAX webinar, you have to know these concepts. This is a prereq for this. We're all very familiar, if you've been paying attention at all, to what's come out of the Northern Institute of Applied Climate Science and others over the past 13 years, these kind of broad categories as to how we think about forest adaptation. And what I've done is borrowed a figure that Brian Palick has developed as part of a paper that he's leading. I'm looking at kind of where does assisted migration fit into these strategies as we look at a landscape like the Northeast and think about forest adaptation. And so again, resistance, right, trying to improve the defenses of that forest against change, so trying to keep it as it currently is. So clearly very little opportunity for assisted migration in that context. Moving along the spectrum, resilience, again, kind of working with that current system, but building in some kind of potential for that system to respond to change, but nonetheless return back to some desired condition. So you may incorporate some assisted population expansion with that, where you might increase the representation of current species that are at low abundance in that forest now, but that might be future adapted, but you're really not kind of moving things in from elsewhere in that environment. And then finally, transition. This is where we might actually use a variety of different assisted migration techniques, depending on what the goal is as you try to get that forest and shift it towards the condition you think will be better adapted for future conditions in the landscape. So one of the key pieces of information that's really been guiding a lot of our efforts as we think about both the vulnerability of future forests, but also what species might grow where in the future in our forests, have been the efforts by Lewis Iverson and other folks with the Climate Change Tree Atlas with the Northern Research Station here in the US. And they've developed a series of products. Again, most of us are familiar with the Climate Change Tree Atlas, where we can look at both the current distribution of species in the landscape based on forest inventory and analysis data, and then also projections of where suitable habitats might exist for those species going into the future. And some of you might not be aware of a brand new product they have generated that now takes that and scales it down to 1 degree cells, so much more fine scale projections than they historically were producing with that atlas. And part of what they've been doing is not just looking at changes in suitable conditions, but also changes in kind of the number of species that might exist in a given area, both based on future climate, but also the potential of that species to migrate. And so this map that we're looking at here on this slide is from a paper that just came out over the last couple of months that they led that shows kind of the potential for new species over the next 100 years across the eastern US based on changing climate regimes, but also based on the ability of species to migrate and so forth. And so if we look at kind of the northern tier of the US and focus in even here in the Northeast, there's quite a lot of potential, up to 16 to 19 new species that might have suitable habitat in this region over the next 100 years, as well as the potential for some of those species to actually migrate into that region. And so when we look at this part of the world, certainly a lot of opportunity if we were interested in integrating assisted migration into what we're doing. The problem, and one that I tend to harp on maybe too much for some of you have heard me talk about this before, is that unlike the Western US or even unlike other parts of some portions of the eastern forest, we aren't expecting stand replacing disturbances that are going to completely eliminate all the overstory trees and completely eliminate all the understory trees over the next 100 years. This is not a part of the world where we have that disturbance regime, and the projections for future disturbances in climate really aren't suggesting we're going to have these cataclysmic events that totally erase the species that currently exist in the landscape. And so when we're looking at these maps, there's often this tendency to think, well, 16 new species can be there, and so in 100 years they'll actually materialize. But obviously the species that currently are already established in the landscape have quite a bit of inherent resilience, and once established can really withstand quite a bit of stress. And so when we're looking at those maps and factoring in assisted migration or any other adaptation strategy, we need to ground that in the ecosystem that we're currently working with today. How do we integrate assisted migration into a forest type that's threatened? How do I work with the current processes in that ecosystem? And most importantly, how does that factor into what the prevailing management culture has historically been in that system? If they're using uneven age methods, how do I integrate planting species in with that? And how does that factor into kind of the broader services like mitigation, as folks brought up in the pre-poll, that might be impacted depending on what we do on that landscape? So just to further point that out, and again, I'm not getting a dime for every time I mention the Climate Change Tree Atlas, but extremely useful resource for us. This is just a summary, and those of you that are familiar with the vulnerability assessment for northern New England and northern New York that Maria Genoviak led with NIACS, this is summarizing some of the findings from that. If we look at just broadly the species that are expected to experience kind of a reduction in suitable habitat on the left-hand side, those that are expected to experience an increase in suitable habitat in the center, and then those that are going to actually gain new habitat in the region, there's some general trends that we can pick up on here in terms of how things are going to be impacted. We certainly see species like balsam fir, paper birch that we associate with more kind of boreal systems are likely to decline. But we also have a range of species that we view as pretty signature species in our forests, like sugar maple, that are also projected to decline in different parts of the region. On the flip side, those either calling in today or logging on today that are from the mid-Atlantic region or from kind of the central hardwood region, the center column looks a lot like where you currently exist. So this notion of some of those species kind of increasing abundance in our landscape as the climate resembles what occurs to the south of us. And then finally, those from the southeast are probably surprised to see cherry bark oak mentioned. This is a northeastern species, but certainly one species that could gain some new habitat. And so all of these can be used as at least a gauge for both vulnerability of the future forest, but also are there certain species that if I was going to use assisted migration, whether it be just population expansion or actually kind of move things around quite dramatically, that I might select from. But the point that's always worth making is that when we look at the actual silvics of these species beyond their ability to deal with climate, the majority of the species that are projected to be future adapted are intolerant or mid-tolerant species. And so as we factor in these species as part of our silviculture, we're not talking about species that can migrate through the understory of a forest. We're not talking about species that will survive very long, underplanted beneath an intact stand. We need to factor in what does it take to actually recruit these species and manage them on the landscape. Taking that a step further, again, as we operationalize some of these strategies, I've honed in for this example into northern New England and northern hardwood forests, and just summarize kind of the average shade tolerance of the species that are projected to decrease in suitable habitat relative to the species that are projected to increase in suitable habitat. So this figure on the left, the higher the value, the more tolerant of shade the species are. And so these are just kind of the average values for those species that are projected to decline. So a lot of our shade tolerant trees are actually supposed to do more poorly. And that's not a big surprise, given shade tolerance and drought tolerance tend to be kind of inversely related for many species. On the flip side, those that are supposed to increase in habitat tend to be much more either mid-tolerant or intolerant in shade. And so the challenge this presents is that, for northern hardwoods as an example, so much of what we do in that forest really revolves around our ability to naturally recruit shade-tolerant tree species, particularly sugar maple, but also, for better or worse, in some cases, a lot of beech, as well as other species. And so if we're now trying to manage for a totally different range of functional traits, how do we integrate that into our current silviculture and work with that system? And so as some foreshadowing for what Kevin will talk a little bit about when he gets into his portion of the presentation, a lot of what we at least think about in these systems historically that have been really important for allowing those species to recruit have been these mesoscale disturbances, things like windstorms, ice storms, insect outbreaks that have been heavy disturbances with still partial disturbance that have been large enough to allow us to recruit those species. And so Craig Lorimer's work from Wisconsin, as well as the great work that Patricia Raymond and Steve Bedard have done in Quebec, have really been influential in thinking about, how do we get some of these future adapted species into our forests? It's going to be through silvicultural systems that emulate those processes. So before I hand it over to Kevin, I'm going to kind of dive into one example of assisted migration that kind of is addressing a different context than exclusively climate change. And I'm going to talk about emerald ash borer and some work that's been happening in relation to kind of addressing this threat in the Lake States region. So again, some folks have heard me talk about this before, but the threat that emerald ash borer plays to all forests is certainly quite acute and quite troubling, both from an ecological, but more importantly, a cultural perspective. But in the Lake States region, there's a pretty unique context in that, unlike what we have in most parts of the Northeast, and I know some folks are from the Midwest and intimately familiar with this, there are large areas, particularly in Minnesota, Wisconsin, as well as parts of Michigan, that are pretty close to monospecific black ash swamps. And so you'll have areas that are 5 to 50, in some cases even 100 acres in size, these large depressional wetlands that are dominated by 75 to 90% black ash. And so with the advent of the emerald ash borer, the concern around that was with these monospecific stands, if we were to lose black ash, there's the potential that we might lose that site to flooding and kind of lose the potential for growing trees on that site in the future. And so there's been a lot of interest from an adaptation standpoint of how do we actually increase the representation of non-ash species in these forests, particularly in advance of emerald ash borer coming, so that we can kind of increase their ability to then respond. So really a resilience type strategy in many cases and sustain those functions. So when we were looking at this, this now has been going on for over 10 years now. It's Brian Palick and myself and Rob Slazak have been leading this work in Minnesota. One of the main areas of interest is, can we plant a range of species in these areas as a way to try to diversify these systems and use a combination of both assisted migration in the form of kind of range expansion, as well as in the form of population expansion, and including actually a translocation of an exotic to enhance kind of the function of these systems going forward. And so what this work did was really look at a huge range of species, everything from things locally present in the ecosystem, and the coding here, anything in orange is not only a non-host for emerald ash borer, but it's also projected to be adapted to the future climate. So we're looking at two different strategies there. So we have species that are already present in the ecosystem. So these are all examples of kind of assisted population expansion, right? We're only just increasing the representation of those species in the landscape. We have 2 species that are assisted range expansion. So here's our study area in the bottom right-hand corner. Here's the current distribution of both swamp white oak and hackberry. And so kind of increasing the representation of those species just to the north of their current distribution. And then actually using translocation of an exotic Manchurian ash. And in the case of this, This is a species that's been shown to be resistant to emerald ash borer in its native range. And the main reason this was included was primarily from a cultural standpoint. Mike Benedict with the Bureau of Indian Affairs, as we were working on this experiment, had done some work with Manchurian ash and was able to actually get splints out of that for making baskets. So the thought was that if we were to lose black ash from this landscape, is this a potential species that could actually sustain some of those cultural values that the system historically had. And so clearly a range of species being planted, a range of forms of assisted migration, all with the goal of trying to both increase the adaptive capacity of this forest in response to emerald ash borer, but also in response to future climate. But a key thing is that if I want to start doing adaptation in an ecosystem, and my MO is that we want to be working with the natural dynamics of the current system we're in. And so a big part of this work was not just planting species, kind of liquidating black ash and then planting species as some mixed species plantation. Really the goal was, how do we integrate non-ash species into current ash forests, and what has been the historic role of disturbance, and how has that occurred over time in these ecosystems as a way to serve as a model for a silviculture in these forests. And so this figure that you're seeing here is just showing the age structure of an old growth black ash forest, so kind of how these forests historically have recruited over time. And so each of these bars just shows the number of trees based on tree ring samples that began their lives in different decades. And if you look at just the black bars, that's black ash. You can see that there's, number one, a lot of black ash in this forest, but number two, a pretty continuous recruitment of that species over time. This is analogous to what you might see in an old growth hemlock or an old growth sugar maple or spruce fir forest. So very much gap phase dynamics, kind of small gap dynamics. And what it speaks to is when we look at kind of non-ash species, those are recruiting into this forest when there's gap events, but we're not seeing any evidence of total stand replacement of that ecosystem. It's just these are small gap scale events that are large enough to allow things to recruit, but not too large that basically the forest would swamp out. So really showing the role that that black ash canopy plays and actually facilitating the ability of other species to establish on that site. And so we planted this range of species across 4 different conditions, replicated 8 times. So we had intact areas where we just underplanted the black ash. We had areas where we girdled all the black ash in 4-acre areas, although for a while we were making money pretending Bigfoot had used these trees as scratching posts. It was good for the tourist dollars up in northern Minnesota. But we slowly killed all the trees in areas to emulate emerald ash borer. We used group selection down the lower left-hand corner to emulate that natural disturbance regime, but then planted into the gaps. And then finally, we did what some folks would suggest, we'll just get rid of all the ash and plant new species. So we clear-cut areas and actually planted those species in that environment as well. So a couple of key take-homes from this, kind of building on what I've been discussing. One key take-home is this is showing survival 6 years after planting. So one key take-home, those of you looking at this y-axis, is that you should probably stop listening to me about planting success. 25%, how credible am I if I can only get that? These are really harsh environments to plant in. We usually don't plant in them, so if nothing else, a good example of the challenges with assisted migration. But if we look at where survival has been greatest between intact, girdled, group selection, and clear cut, really the general trend is that when we plant trees into these areas, having a canopy present is critical. And what that's speaking to is that even though this is a novel threat, the natural rules of this ecosystem still are governing what's happening out there. Even though black ash is a threatened species, we still want to be integrating assisted migration in a context where recruitment of non-ash species occurred in the past, and that was not in big openings created by clear cutting. So really trying to work with the system. The other thing that's been interesting about this work is just what has done best across the seedlings that we're planting. And so what we're looking at here is percent survival by the different species we planted. And then I've kind of categorized these into different categories of assisted migration. So American elm was a combination of both range expansion and population expansion, because we were using both a local seed source, but also crossing that with a disease resistant source. Swamp white oak was range expansion, Manchurian ash, translocation, hackberry range expansion. And then the remainder of these really, again, would be categorized as either enrichment planting or population expansion. What we have found by far is that the highest survival are for species that weren't currently on the site and really weren't currently in the region. And so if we hadn't been integrating assisted migration into our thinking in addressing emerald ash borer, we wouldn't have included those species in our list of things to evaluate on that landscape and may have missed out on what is actually a promising adaptation option on these sites. And so, if nothing else, this notion of assisted migration as a tool, as well as this ability to possibly integrate it into our adaptation actions, may provide some chances to see things that we weren't planning for in the past. So I'm going to transition from actually a landscape, the Midwest, where it's fairly straightforward in some cases to get lots of material and do lots of planting, to kind of the Northeast and talk about and turn it over to Kevin to talk a bit more about kind of if we were to operationalize assisted migration, but also think more broadly about adaptation of the landscape, how that's occurring. And before Kevin gets going, just and one positive as well in terms of all these threats, I guess, I'll point to is that I've been able to work with Kevin in the landscape he's going to describe and work with just both his stewardship and also Dartmouth College in a pretty sweet slice of the world that you'll all get exposed to now. So Kevin, you can, I guess, take the baton from me.
Okay, thanks, Tony. That was a good introduction. Yeah, we're going to probably bring it down a little bit into a little smaller scale, I guess, and look at assisted migration on one property. For those of you who don't know me, I am the Dartmouth College Forester. I manage all of Dartmouth College's timberland, about 42,000 acres. And we're going to talk about a small piece of that. And today we'll talk about an experiment we've been working on with Tony at UVM about assisted migration and kind of adaptive management and in a bigger picture. And a small part of that experiment is assisted migration. And from my point, I think about this from a manager's standpoint and the fact of how do we manage the land today for the trees that we expect to be there in the future. And so you can switch the slide, Tony. So back in 2015, the U.S. Forest Service and UVM came to the college and asked us if we would like to be part of the Adaptive Silviculture for Climate Change network. We were excited about that, and we decided to go ahead. I think the thing here is maybe a couple of key points, that this is a co-produced experiment looking at multi-regions. You can see the sites across the country, that it is scientist and manager driven, that the sites be replicated, and that it be really locally derived. We can switch the next slide there, Tony. So in the summer of 2016, we decided to sign an MOU with UVM and the Forest Service, and we picked a couple of sites on our property to start thinking about this co-produced management. Maybe a little background too about the grant. The grant's a 27,000 acre property that Dartmouth owns. We've been managing it since 1807. We've been cutting timber there since about 1828. We've had a forester there on site since 1905. We've had a management plan in existence since 1947. And we like to think of ourselves as a working forest. We've been harvesting about 7,500 cords of wood off from the property for the last 30 plus years. We're dominated mostly by northern hardwoods and mixed wood. So we chose two sites. One is a northern site. We call those blocks 3 and 4, and the southern site is blocks 1 and 2. In the fall, in August of 2016, we started to pull together and co-develop the study. We brought together about 15 or 20 scientists and managers onto the site for a 2-day meeting to start to decide what the cutting treatments would be for these specific sites as they related to climate change. We can flip to the next slide there, Tony. So we worked in that same resistance, resilience transition that Tony talked about before, and we decided that we would replicate the thing 4 times. So each one of these treatments is 25 acres. It's replicated 4 times. So each one of the treatments is 100 acres. And we have 4 control plots also. So the first one is kind of the single tree selection. I think mainly kind of doing it the way we've been doing it for the last 30 years, looking at trying to keep our basal area somewhere around 70 to 80 square feet, really trying to keep some kind of uneven aged structure there, good diameter distribution, and looking at sugar maple as our dominant species. The other thing we were looking at was to, how can we look at these in a context of climate change and in our marking priorities. Maybe we were favoring resistant beech, and that we would look at, if you look at that picture there in the middle, you see a great wide top tree that's probably not very good when we start thinking about ice storms. And so how do we thin out some of the susceptibility to ice storm, and how do we maybe recruit in yellow birch, which is maybe a little bit more adaptable to being iced. One of the other things we looked at is to trying to increase our downed woody material. And we also had a hydrologist who was part of our co-development that was worried and wanted to look at these episodic events of high flow events where the water rushes across the landscape. So we dropped 1 to 2 trees per acre perpendicular to the slope and left them not only for down woody material, but also to maybe stop that flow from going across the landscape. Our next treatment was resilience, and here we took a look at how can we do things a little bit differently. I think Tony talked a lot about the fact of looking at tolerant species to more intolerant species as we move along. The fact that a lot of those species that will be moving into our area are going to be species that are more intolerant. So here we looked at group selection and single tree selection. That 20% of our landscape would be in 1/10 acre, 1/4 acre patches, and then 20% of the area would be left in reserves, uncut, and then we would thin through that matrix. Really trying again to think about a different approach than our normal type of cutting, and how we would start to think about regenerating different species, and really looking at wind and ice, resistant species like yellow birch, red maple, and red spruce on those sites. And then our last one is our transition. And here we're looking at trying to, really kind of start to stretch out there and look really at how we can get those future adaptive species there. Looking at a continuous cover, irregular shelterwood. And in there, we would have 20% of the forest in 1/4 acre gaps or 1 acre gaps. And in those transition cuts, we would have 3 cuts of 1 acre in size. And that's where we would start to look at this future adaptive component through planting. And we'd also, I think you can see in that upper left-hand photo, you can see some of those larger retention reserve trees that we tried to leave. We tried to leave 3 trees per acre cut. mainly looking at beech and yellow birch, but also thinking about red maple and red spruce in those cuts. And we can switch to the next one. So as we move along, in 2017, we were able to go out and actually cut and harvest those 4 sites. You're looking at a LiDAR image of the northern site, block 3 and block 4. If we look at the range of the colors, blue indicates low tree height, and the red indicates higher tree height. So if you take a look over at that northern side, you see those 3 nice big yellow dots. They correspond to those 3 nice big blue areas. So those are our 3 1-acre cuts, and the other ones are our 1/4-acre cuts. So if you think about it in terms of the whole, the block and the transition through, if you start down in the lower left-hand corner, that is our control site, kind of the blue shaded around it. Then we move into the transition cut. And then as you come up, you come to the resistance. And then the next one is the resilience cut. You can kind of see those 1/4-acre patches there. So we can move on to the next slide. So in those 1-acre patches and the 1/4-acre patches, this is where we decided to look at assisted migration. And in those patches, we planted these 9 species. So red spruce, eastern hemlock, white pine, big-tooth aspen, American chestnut, bitternutt hickory, black birch, black cherry, and red oak. Planted 6,500 bare root seedlings in these sites. The chestnut was planted from seed. So probably the one thing we did is logistically we only planted in these clear cuts. Didn't try to plant in any of the other the cuts. And if you look down through the future habitat, as Tony talked about, we looked at red spruce and eastern hemlock. Says they're going to decrease. We also don't have a lot of softwood species to deal with and work with, so we chose red spruce. Our ownership probably could increase its amount of red spruce in these cuts. Our hardwoods don't have a lot of softwood in them. They've been cut out over the years, so we felt like this was a species that we could maybe increase and do a little bit better. The eastern hemlock, here we kind of thought that we might be able to increase its numbers on the grant, and that the fact that its reason for decreasing is probably the hemlock woolly adelgid, and that maybe here we could be a refugia for the hemlock and not have it. They refer to the grant as the snow bowl, so maybe we would have cooler temperatures and we could do away with that. And all these species that we chose them using the tree atlas. And the others would have no change. I think the ones we're looking at increasing, we have black cherry on the site. It's really at the tip of its range. It's not very good quality, so maybe we could increase and help that black cherry out. Red oak being another one that's kind of in the area, but is not on the property, and hopefully in the future we could get more of it out there. We can flip to the next one. These are the survival rates of the seedlings that we planted. This is 1-year survival, and I think if you look at this slide compared to Tony's, the population expansion trees seem to be doing pretty well, where the range expansion trees are not doing as well. And I think that that's kind of expected in the fact that we're trying to push that range up into a place that, you know, the climate probably is not quite ready for them yet. There's that kind of lag response to when those trees should be here. So we can flip the slide. The ideal approach in the way we looked at this was using something like a seed selection tool. So if you choose a place to plant like the Green Mountain National Forest, you want to be picking your seed source from where you think your climate is going to be. So if we look at where's the climate that's going to be the same as Green Mountain National Forest in 2055, we have this black area. So we probably want to be looking at the seed sources and stuff to come from somewhere within that that black area. And if you're looking at 2085, you look at the red area. We can switch to the next one. The challenge gets to be that you are very limited in the capacity of where you can get these seedlings from. And when we started out on this, we ended up having to get all of our stuff from two nurseries, one out in the Midwest, and then we were able to get some stuff from the New Hampshire nursery. So if you're looking at that, you know, opportunity of nurseries, you know, state nurseries have been either closing or, you know, definitely not expanding. And so if you're looking for that seed source, you're limited in where you can get it and how you might want to procure it. So flip to the next one. And then you run into the problems of how you're going to think about planting. And one of the problems, and I think from a manager standpoint, and from my standpoint, is planting has always been a minor component, if not a non-existing component of our silviculture. All of our silviculture has looked at how do we get the tree species on the land via some kind of silviculture and some kind of cutting. And so you start to run into how do you get the trees out there and get them planted. There's the cost associated with the trees. How do we look at that? Your infrastructure. When 10,000 seedlings arrive at your doorstep, where do you put them, and how do you keep them cool? You can stuff them in your refrigerator, but the problem that we found was seedlings coming from Michigan were probably on a truck for 3 or 4 days. It was hot. When we opened up the packages, they had started to bud, they had started to mold, and then we had to try to keep them cool. You then have a bunch of people who have never planted trees before in their life trying to get them in on rocky, steep terrain with all kinds of brush and ledge. And then when you're moving those things, as with the slide down the bottom, you're trying to get them 3/4 of a mile up in the woods to a rocky, very steep site. You've got other problems. So, you know, I don't think planting your way out of everything is as easy as we think it might be. We can slip to the next one. So the other problem is you start running into also the thing you're trying to figure out, and that's climate change. And so here on the right-hand side is first-year survival at the second college grant, and then Tony planted 2 sites as kind of controls over in Vermont to see how things were doing. The first day we were out there planting in the clear cut, it was about 80, 90 degrees. And then if you look at the slide over, you start looking at the drought index for June of that year, and both of our northern New Hampshire site and our Vermont sites were right inside of a pretty good drought. The sites on the college grant, we were lucky enough to receive rain within the first 5 days, but the Vermont sites didn't receive rain for almost 15 days. And they also, you see that star over in New York, they also ran into the same problem in Tug Hill where they were doing another adaptive planting. So here again, even the episodic events that we get, these 2-inch rainstorms in 40 minutes, then end up getting a rainstorm for many, many weeks, is probably not helping out planting and over the long term. And we'll go to the next one. So here we're looking at the regeneration and how it did through the different, the control all the way through the transition. I think just looking at the slide is what we would expect, that as you are in the resistance and you've got crown closure and you've got trees being shaded, it probably resists drought a lot easier, and the fact that they are covered. As you move into those much more open areas, then you start to see that regeneration starts to show some droughtiness. I think what we take away from this slide is that, you know, we need to be looking at climate change. There's a risk to planting things, but if that climate is going to change such that we're moving species around, having those trees out there, or, I mean, if we looked at the graph of how many trees were surviving, 45% of them were surviving. So at least some of them are going to be out there. And maybe the risk of doing some planting is worth it. I think my thing about the whole thing is that, you know, through this whole approach, we need all 3 of these cutting regimes and things to figure our way out of the climate change and how that is going to affect managers on the ground. So I think that's my end of the operationalization of it.
Thanks, Kevin. And yeah, if you didn't notice, that was Kevin on the 4-wheeler carting seedlings around everybody. So he does everything to steward that landscape. And so just to wrap this up before we can start addressing different comments and questions from folks, obviously, you know, the way that we're reviewing this and the way that it's been presented, and I'm sure many of you have been thinking of it, is that, you know, assisted migration is not the only way we can do adaptation. Really, it's a tool that's out there and one that's kind of integrated into this broader suite of tools that we're using and approaches, and sometimes even reframing of what we've always done, just in the context of global change and addressing those. And again, to be a skipping record on this deliberately, you know, we look a lot to the future and kind of how much the forest is going to change, but really we need to really think about how does this fit into kind of the day-to-day operations that Kevin does in the landscape, as well as how does it fit into the ecology of the forest that we're currently working with. You know, both from the perspective of retaining some of those mature structures just from an ecological standpoint, but also in some cases ensuring that we actually have success with these species, as opposed to kind of putting trees into a situation that has no natural analog and certainly would have pretty high likelihood of failure. One of the things that we ran into, I guess, being the one that paid the bills on the seedlings, and also someone that's worked in other parts of the country on assisted migration projects, as well as on just general forestry work, is that we really are a region that is disadvantaged as it relates to our nursery capacity. We don't even have seedlings, let alone seed zones, and so kind of the ability to be sophisticated with our assisted migration or even operationalize it is pretty limited, as Kevin pointed out. And so if we really are going to integrate this into what we do, I'm certainly using the existing materials available to us might be worth the risk, as Kevin mentioned, 45% survival. But if those trees do survive into the future, that'll be a good thing. But nonetheless, if we're going to view this as something that is a bigger part of what we do, we need to be thinking about what the capacity is, both for different seed zones, but also in the context of the black ash. Many of those species we planted were not traditional timber species. And so if we have unique restoration or adaptation examples that are going to need materials that aren't typically sourced, building that capacity is going to be pretty critical. And I know Greg Edge and others with Wisconsin DNR have already been highlighting that with lowland forest work. And the final plug, those of you that are interested, the planting's over, so it's just a fun walk in the park now, and you're up at the second college grant, at least for visitors like me, is that in mid-May, there will be a tour as part of the 30th annual Coos County Foresters Mud Season Breakfast. So those of you familiar with that event or close enough in the region to attend, there will be an opportunity in the near future, as well as many more going forward, to see this on the ground. And most importantly, beyond the adaptive silviculture for climate change site, see more broadly the amazing stewardship that Kevin's been doing out there for over 3 decades. So lots of folks have been helping with this. Kevin's not listed, he's on the first slide, but he should also be like on the last slide, but as well as many funders and so forth. And we'll certainly open it up for questions.
Awesome, thank you. So we had a few questions come in. In the interest of time, let me just make a brief announcement. At 1 o'clock Eastern, in 5 minutes, we will formally conclude, but if people still have questions that they want answered, then our speakers are happy to stick around for a few minutes to help answer those. So questions, we had a couple that came in related to species, and Maria pasted some helpful resources into the chat box. So I'm gonna, in the interest of time, move ahead. Mila had a clarifying question. She says, it was difficult to tell if the plantings that Tony described were species that were normally found in the area or not, excluding the new ash species. Would you mind clarifying, Tony?
Yeah, so it was a mix. A large proportion were actually species found at very low abundance in ash swamps. So as I mentioned, a lot of those areas are anywhere from 70, in many cases, over 90% black ash. And so we did include less common species so that they at least shown some ability to survive on those sites. So, but then there are also 2 species, swamp white oak and hackberry, that were not currently in that region, although there were a couple of satellite populations to the north historically. And then Manchurian ash, obviously, it was grown in the U.S., but the seed source was from China.
Got it, thank you. We had a couple questions for Kevin. One was, were there any sort of steps taken to mitigate deer pressure on the planted seedlings?
Yeah, 50% of the trees were protected with a little, I won't call it a tube, but a thing that deer couldn't get in and eat them. If you look at this last slide, I think the other thing that you need to realize about the second college grant is that herbivory is not one of our problems. We don't see a lot of deer damage. We probably see more moose damage than deer. Since our snow, the first year these seedlings had 65 inches of snow over the top. So snow is a big factor here. And our deer populations are probably only about 5 to 6 per square mile. So a little different if you're in New York and Massachusetts than if you're up here in this part of the country.
Yes, indeed. We had another question for Kevin. How useful was the New Hampshire Forest Nursery for sourcing? It sounds to me like they were able to partially supply the project. How was the mortality of the seedlings from the state nursery?
I think Tony can probably talk too about it, but when I received the seedlings from the New Hampshire nursery, they were way better than the ones we got out of Michigan. And I think it was the fact that it was a day shipping, not a couple of days to get them out here. And the red oak that we got from there was just a super stock. They were really high quality seedlings.
Nice. All right, we have a couple minutes left. Oh, go ahead, Tony.
Yeah, I was just going to say, what we got was great. Unfortunately, there was just a limited amount. And ironically, us planting the same year as that big Tug Hill adaptation demonstration in New York, they basically used up most of the capacity of the New York nursery for some of those seedlings. So on their project. So the stuff from New Hampshire was great, but we didn't have a lot of, even red spruce they couldn't source. That came from the Michigan nursery, ironically.
Yeah. We had another question that came in. Have you seen any species migration of wildlife or understory with movement of the trees? Is it too soon to tell?
I think it's too soon to tell, but one key part of this project from the wildlife standpoint is Ryan Stevens and Becca Rowe at University of New Hampshire are part of this work, and they're looking at small mammal abundance and their role in distributing spores of mycorrhizal fungi. And so 7 of the 9 species we planted we use arbuscular mycorrhizae and 2 ecto. And so different small mammals are responsible for distributing different species of mycorrhizae. And so one of the things we're interested in is, over time, are the seedlings we're planting actually getting like the microenvironments they need to survive based on the current behavior of the small mammals and so forth in that landscape. But it's probably too soon to see any response of species to what we're planting, but we're more interested in, at least initially, how like small mammals and other things might influence their survival and health over time.
Cool, thanks. All right, so we're at the top of the hour now. I'm going to leave you, and again, if you have questions, please stick around. I think Sarah wanted her question answered about math earlier, but I'm going to leave you with a few links that will be helpful. For one, if you're a forester and you are looking for credits, I provided a link to the certificate of credit assignment. If you need more than that, please let me know. I'm also going to be submitting the list of everybody who has participated to SAF for inclusion in your records. You have to be here for the better part of the hour to be included in that list. We also have a link to the Forest Climate Adaptation Needs Assessment that was just published, and also the more information on this webinar series. I know a lot of folks are going to want to jump off, and again, our speakers are going to stick around to answer some more questions, and we'll start with Sarah's question. But again, let me just please join me in a quick huge thank you to our speakers for this really, really interesting presentation on assisted migration. Thank you. So with that, we're going to roll on. So Sarah had asked a question earlier, and she said, is there an increasing species that is similar in mass value to beech? Acorns have half or less of the protein value of beech and less fat. Just wondering how this will impact wildlife.
Yeah, I think, when we were looking at potential species to plant, a lot of what we looked at was the functional, role of those species relative to what currently existed. So you're right, both hickory and oak certainly don't have that value. Chestnut, definitely has quite a high value from that perspective, but obviously who knows if it will live more than 15 years in these sites. But one of the things that really is critical about what we're doing out here is when Kevin mentioned that we were leaving behind beech in these openings, we would deliberately retain trees that had active bear activity on them, and so really those trees that were being sought out for bear habitat and for beech nut production. And also, I read the Climate Change Tree Atlas, and many of you are familiar with it. My perspective is that beech isn't really listening. And so even though it's projected to decline broadly, that's a species that has tremendous ability to adapt to changing disturbance regimes. Yes, there might be increasing stress on that species, but it'll be a long time before beech would be lost from the landscape. So I think it's still going to be a big player over the next 100 years in these areas. But nonetheless, we tried to bring in some other species that at least had some value as mass species. Maybe not the exact equivalent for beech, but we definitely were factoring that in with what we were putting out there.
Great, thank you. Kevin, do you have thoughts on beech that you want to share?
I think people have been trying to get rid of it for many years, and it's, as Tony said, it's just not listening. So, but I mean, I think the other thing as you kind of look at this slide here, and it shows the retention trees in those clear cuts. The top priority for leaving trees inside of there was beech. And so, the highest value was beech is the one that we want to leave behind so we can continue to have that. So, yeah, I think beech to most people's chagrin, I think when we talked about trees to leave and trees that we were going to, try to promote, when we mentioned beech, it kind of made everybody cringe, but it's an important carbohydrate for us.
Great, thank you. You had another comment / question. Tony, Kevin, this is great stuff and important to understand. Yet I'm struggling to understand how this type of project would scale up to have a long-term landscape effect. Can you share your thoughts about how much effort the forest management community should be implementing in these techniques?
So from my perspective, I guess to my cynical response is, my role, I guess, from a research standpoint is that we need to kill enough seedlings to prove it's not as simple as planting our way out of this strategy, out of this predicament. And I think all of us recognize that, but oftentimes it's presented in a pretty black and white case that we can just plant these new species and we'll be just fine. Nonetheless, I think the way that I tend to look at the transition treatments and the reason why we're only planting in those kind of isolated, 1 acre to quarter acre to 1 acre openings is that, maybe 45% of the red oak survive in that spot. But over time, as those mature, they might be a very critical seed source for the broader landscape as things change and dynamics start occurring. And so my strategy has always been, when I look at this, is it's part of kind of a broader suite of approaches. You notice that really the only kind of adaptation strategy that we're planting in is the transition one. And so the thought is that we're working primarily with the current system, kind of using the mechanisms that system has already to be resilient, resistant, and even to some case kind of adaptively respond to climate change. But these plantings are being kind of at a limited scale integrated in that over time, as things change and as the kind of broader landscape has climate conditions and disturbance conditions that are more suitable for those species, we already have some local seed sources in the region that might be kind of useful for kind of the broader region, thinking of the ownership of the second college grant being one of those. But I don't think we want to be kind of, every single site has to be integrating assisted migration. Nonetheless, where those opportunities exist, those could be critical places going forward as seed sources. And some folks even talk a bit about our urban and suburban plantings serving those roles as well, having these trees in places that we normally wouldn't have them just because of people planting them in the yard could be useful, or as we've seen with invasives, a problem. So it could cut both ways, but in this case, we're planting native tree species at least.
And I think from my perspective, it's, as Tony said earlier, that we need to start thinking about the fact that the trees aren't all going to disappear at once, but how we're going to, and what tree species we're going to have. I think we need all those approaches, a little bit of planting, some resistance, some resilience, and look at the controls and see how that works over time.
Great, thank you guys. That sounds like a good question to end on. We might give folks just another moment to type in a question, but I think that sums up kind of the direction that this assisted migration project is going in. While I'm stalling for anybody who's typing in their question, I just want to reiterate that something that's really great about the work that both of you are doing is that you're not letting climate change overwhelm you. Yes, it's a huge problem, but you're working on trying to do something about it. So overwhelming or not, uncertainty or not, you're still making an effort. So thank you for all the work that you're doing. Looks like my stalling technique worked. We had a couple of questions that did come in. So if you're willing to stick around, speakers, then please, we have a couple more questions. And thanks again for everybody who's listening. So Alex asks, I've heard a lot of worry about assisted migration causing new invasive species problems, moving species to new areas with low understanding of how they'll respond. Can I just hear your thoughts?
Yeah, I mean, I think there certainly is, particularly as you move into that translocation of exotics category of a risk of having some unexpected behavior of a species in that landscape. And so I think, at least from my perspective, a lot of what we've primarily felt comfortable with is both obviously assisted population expansion, but then kind of that range expansion where you're just moving that species a bit north, but not necessarily taking a species from a different continent or even different part of the country. The drawback to being afraid of that risk is you never know what's going to be. All of a sudden, swamp white oak be an example, for the black ash. Again, I always hate saying that that's proven to be the solution, because it's only been 7 or 8 years, but so far it seems like it's doing quite well on those sites. If we hadn't at least kind of pushed that envelope, we would have missed maybe the potential to include that species. Nonetheless, Manchurian ash is one that we were all very uncomfortable with, and actually to this day, I'm really happy that it survives, but it doesn't seem to be going anywhere. It's not very tolerant of cold, so it's just kind of resprouting. But we have similar concerns about that one, and actually our plan when that experiment's over with is just to kind of eliminate that species from where we put it on the ground. So I think it's a risk worth considering, and there is a lot of work that's looked at what traits make certain species more invasive than others. But from my perspective, right now it seems like a lot of the promise is working with species that are currently in the eastern U.S. And so maybe it's nudging that range just north or just west. But I think we should always be cautious about taking species from somewhere else and putting them here and assuming they're not going to behave differently than their native range. So I think it's worth bringing up, and I appreciate you raising that point.
Yeah, good thoughts. Kevin, did you have thoughts on invasives versus assisting existing species?
No, I mean, the other thing for me is just in talking about invasives, and it may not be that tree species that you're bringing, but when you start bringing nursery stock in from somewhere else, maybe you want to think about, we only planted bare root seedlings. Maybe you want bare root seedlings rather than containerized, where something could, nurseries are growing all kinds of things, and you may get something from the nursery that you don't want.
Yeah, another good reminder. We had a clarifying question. Mila asked, she says, I'm grateful to hear both Tony and Kevin answers to questions. It sounds like Kevin has a similar attitude about hemlock as we think of ash trees. Hope to keep managing for their resiliency if possible. Did I get that right?
Yeah, I believe so. This actual stand has a bunch of white ash in it, and we thinned them out and grew them. Yeah, this may be the refugia area for white ash too.
Great, thank you. All right.
The only problem with planting the hemlock is you got this tolerant species that you're trying to put out in a clear cut, and that's why it just didn't do very well. It wasn't the fact that the climate here was bad for it. It probably would have been better to be planted in the resistance or resilience than the transition.
Interesting. Well, there's a lot more subtleties to think about. I think at this point we probably ought to wind down. And again, as Tony mentioned, the Mud Breakfast is going to be featuring the Dartmouth Second College Land Grant. So if you want to get your chance to get behind the gate and see this work in person, check out the New Hampshire Mud Season Breakfast. All right, so we'll wrap it up. A huge thank you to our speakers, to Tony and to Kevin. This is really, really, really interesting. And there's a lot more work to be done. Thank you for sharing the work that you're doing.
Thank you.
Yeah, it's great.